The project here is a timer. The timer itself is a block command identified as timer, timer number T1. It is going to count to 100. Now this timer is going to count in tenths a second, so it's a 10-second timer. When I energize the run, that turns the timer on. When I break the run circuit and break the logic, it's going to reset the timer back to 0. Now we are going to compare or use a comparison on the timer's accumulator. So on this statement on line 2, we have timer accumulator 1. So timer 1's accumulator going to be greater than or equal to 30. The output turns on. Line number 3, timer 1's accumulator less than 70. The output's on. Then we have a variation, what could be a limit command. Timer accumulator 1 greater than or equal to 30. Timer accumulator 1 less than 70. So as long as that accumulator is between the numbers 30 and 70, this output will be on. Once the timer reaches the preset, the done bit turns on. Once that timer reaches the preset, the done bit turns off. Now we go ahead and connect to the PLC. Use the disk version of the program. And I write the program to the PLC. This erases all the memories. Okay, we check the status, and there's my timer. Timer's activated. Now the timer itself activated, if I break the logic, right up here, break the logic, the timer resets to 0. Timer 1 counts to 100, and this is the accumulator value. Well, right now that accumulator is at a 0, which is less than 70, the output's on. This contact right there is closed because the timer's done bit has not been activated. But once I turn on the run command, it now has logic. The accumulator counts to 100. When it becomes greater than or equal to 30, the output's on. Less than 70, the output will be on. Between the numbers 30 and 70, the output would turn on. But now that this is activated, I break the circuit. Momentarily restart it. So now we have a whole system that works, and it can work virtually any way we want it. Anytime we need a time frame. So the timers do have a limit into how much they will time. And that's going to be 9,999 is the highest count it can get of whatever value we use. So by using timers and counters together, we can actually create a clock. We reset it again, and it continues. Timer 101. Now there's other variations of timers. We'll look at another one here. This is a retentive time-on timer, so it's going to retain its count. So the graphics a little different, a little bit bigger box. Timer 1 counts to 200. Okay, that's going to activate when I close my input X0. Now I can also reset the timer manually by pushing the button connected to X1, or when the timer times out, the contact will close, resetting the timer. Well, again, we have the conditions. We're comparing the timer's accumulator greater than or equal to the number 30. Comparing the timer's accumulator less than 70. Comparing the timer's accumulator greater than or equal to 30. Compare the timer's accumulator less than 70. Then we have the outputs of the timers. Well, timer done bits. One open, one closed. Now go ahead and connecting to the PLC. We use the disk version of the program and it runs. However, we got to write the program to the PLC. If we don't write the program, it'll never get to the PLC. So we write the program, erasing the other programs. We click on the status file to see the program run. Now, once we click on that status, we got the highlights blue that tells us the condition of the program. I push the run button. Now, when I start the timer, all I have to do is push the input that's attached to X0. When that does, the timer activates and it counts. It's going to count to the number 200. Right over here, the number that's moving is the accumulator value. Once it reaches the number 200, okay, the timer will reset itself. You don't see this contact close, but it only closes for one scan. And as we look at the conditions, greater than or equal to 30, the output's on. Less than 70, the output will be on. Well, right now we're going to be ready to reset it and it starts over again. There's the output's on. Now we're going to operate between the numbers of 30 and 70. The output's on. So we have timers that do different types of work. The difference of this one is if I kill the power on this one, it retains its current accumulator count. So if I start it again, it starts where it left off. I stop it and it holds. It retains its current count. This is called a retentive time on timer. Now the other timers, when I break the logic, will reset. This one does not. So there is a difference.